Hi everyone. Last time we talked about linear time, where the work grows in a straight line with the input. If you double the input, the work doubles. So today we are going to look at something that grows much faster. It is quadratic time. So the word quadratic comes from quad, meaning square. In math, a quadratic function is something like n square or n times n. So quadratic time means the number of operations grows like the square of the input size. Imagine you are at a party with n people and everyone wants to shake hands with everyone else exactly once. So how many handshakes happen? So the first person shakes hand with n minus 1 others and the second person already shook with the first. So they shake with n minus 2 new people and so on. So the total number of handshakes is about n into n minus 1 by 2 and which is roughly n square by 2. So the handshakes still proportional to n square. So in this way, if you have 10 people, you get about 45 handshakes. And if you have 100, you get about 4950 handshakes. So that is 100 times more people. So let's see a simple programming example. Suppose you want to print a multiplication table for numbers 1 to n. That means for each I from 1 to n, you multiply by each j from 1 to n. So how many times does the print statement run? So here for n equals to 3 and I equals to 1, the j would be 1, 2 and 3. It is 3 prints. And for I equals to 2, it is 3 prints. And I equals to 3, it is 3 prints. So the total prints would be 9 prints. So the number of prints is n multiplied by n equals n square. So that is pure quadratic. So here I plot linear n and quadratic n square on the same graph. For small n, they might not look too different. So this is why computer scientists worry about quadratic algorithms. If you have an algorithm that order of n square and you try to run it on a million items, it will take an enormous amount of time, much worse than linear. So linear is like walking. It takes twice as long to go twice the distance. And quadratic is like if you tried to visit every pair of cities, the number of trips explodes. A very common task is checking if an array has duplicate values. One simple way is to compare every element with every other element. We can do this with two nested loops. Here, outer loop I goes from first to last and inner loop j starts from I plus 1. So we don't compare an element with itself and we avoid comparing the same pair twice. So how many comparisons does this make? Let's count. When I equals 1 and j goes 2 to n, it will be n minus 1 comparison. And similarly for I equals 2, it will be n minus 2. So I equals n minus 1, then it will do one comparison only. So the total will be n minus 1 plus n minus 2 plus 1 equals n multiplies n minus 1 by 2. So it will become n square by 2. So it is roughly n square by 2, which is order of n square. Even though we cut the work in half compared to n square, for large n, this too does not matter. The growth is still quadratic. We use big O to ignore the constants. So n square by 2 is still order of n square. That is why we say this duplicate checking algorithm runs in quadratic time. How can you look at code and guess it is quadratic? The most common sign is nested loops, where both loops go up to n or depend on n. But be careful, not every nested loop is quadratic. Look at this. Here, the inner loop always runs n times, no matter what n is. So total operations is n multiplies 10 is 10n. So it is linear, not quadratic. Here is another tricky case. Even though j starts from I, the total number of iteration is about n square by 2, so it's still quadratic. So the rule, if the number of times the inner loop runs depends on n in a way that multiplies with n, it is usually quadratic. If the number loops iterations are fixed, like 10, it is linear. But quadratic algorithms can be too slow for large inputs. Let's imagine your computer can do 1 million operations per second. So for n equals to 1000, the linear time complexity would be 0.001 seconds, and the quadratic time complexity would be 1 second. And for n equals to 1 million, the linear time complexity would be 1 second, and the quadratic time complexity would be 1 million second, and it is around 11.5 days. That's the difference. That is why when we write programs that handle large data like Google searches, Facebook friends, we must avoid quadratic algorithms if possible. We look for more clever ways like sorting fast or using hash tables to bring it down to linear or log linear. So let's recap what we have learned today. So that quadratic time means the number of operations grows like n square. When input doubles, the time roughly quadruples. And we have learned common examples like nested loops that both go up to n, checking all pairs, multiplication tables, etc. And we write the quadratic complexity as order of n square. And the quadratic can be too slow for large inputs. So always try to find a faster way. So great. Now you have understand quadratic time. Next time we will look at logarithmic time, which is even faster than linear. But for now, remember, avoid nested loops when n is large.